Welcome to you all. Good morning, Ryan, and thank you for joining.
Good morning. Thank you for having me.
Great. So first question, maybe you could introduce yourself and share a little bit about your professional journey to the current role of President of Commercial Satellite Systems International at Boeing.
Yeah, you have to. So I started in the industry back in the mid 90s when, the industry was trying to figure out what to do with the commercial Ka band for data communications. And since joining Boeing over 20 years ago, I've been, I think, very lucky to be part of some of the more leading edge digitized communication platforms that we put out, starting with the Spaceway program, which was one of the first Ka-band kind of broadband space platforms, doing mobile platforms with Thuraya Telecommunications, for example. About half of my career spent as well in the government communications business. So working with the military and other parts of the United States government on communication solutions. Most recently, leading the O3b Empower program, which is the launch of our 702X, our kind of fully digital software-defined satellite. And now quite lucky to, and maybe humbled to be at the helm of this very long legacy, this long history of sophisticated space communications and carrying that forward.
That's a great journey, and surely you've seen a lot, on the forefront of some of these latest technology evaluations or evolutions, I would say. So diving into the topic of today, obviously in the conversation with the satellite industry, it's all about software-defined satellite these days. So let's talk a little bit about that. And maybe could you tell us more about how you've doubled down on this whole digital satellite-defined technology and what it kind of means from your perspective for your customers? You still with us, Ryan? Do you want me to repeat the question?
Yeah, please. You froze there for a bit.
Sorry.
Apologize.
That happens in these environments. So hopefully powers will not be able, we don't have to deal with these things. But so the topic is, as we kind of highlighted in the introduction as well, it's all about satellite, software-defined satellites these days, right? So I was wondering, if you could explain us a little bit more about how you've doubled down on this old digital satellite technology trend and what it kind of means for the operators, for your customers.
Mm-hmm. Sure. So as I noted, Boeing has been doing digital platforms, digital satellites for well over 20 years, and what that has enabled for operators is the ability to move power, bandwidth, to provide that flexibility once the platforms are on orbit, in order to adjust to changing market demands over the 15, 20 plus years that the satellites are in orbit. What we've done with the 702X platform, it's kind of taken that to the next level, where the entirety of the satellite is software defined. So we have a very, I'd say it gives us a standard yet bespoke solution. So the satellites are fully phased array, which gives the operator from the as the market changes, if they want to move the satellite to a new geographic region, to do some exploratory, new market entrants as they come up with new ideas for solutions that can be provided from space, especially as we're moving to a much more sort of networked world in space. It gives them that complete flexibility to move power, move bandwidth, change coverage areas, and what have you. One of the challenges one of the conversations we often have with satellite operators is, when they have to design a satellite, when they kind of define a coverage area, they really have to get it right, and get it right at the outset, thinking ahead what the world's going to be like 15, 20 years into the future. And I think we've seen technology moves much too fast these days to be able to predict with a high degree of certainty. And so a lot of times our operators will say, well, we put some cover, we designed a satellite with coverage in this region, we find we're really not getting much uptake, or we've discovered there's this new market emerging, and unfortunately it's just a bit outside what we can access from the assets we have. And so with fully software defined satellite, that limitation really goes away. You can change the beam size, shapes, move power, move bandwidth, have access to the entirety of the commercial Ka-band spectrum in the case of the kind of the Ka-band version of the 702X, and it kind of eliminates that constraint.
So yeah, no, the flexibility is clearly a great feature of the new trend. And but are there some other trade-offs for operators to consider? Is this kind of, you think that this solution fits all, or are there maybe still some circumstances or use cases or business cases where, different, the trade-offs goes maybe in favor in for other options?
Yeah, definitely. I certainly don't believe in a one-size-fits-all solution for everybody's for all of the operators' challenges. And in fact, as an example, we are right now manufacturing very traditional-looking C-band satellites for SES as part of the C-band spectrum clearing, and that is really the right solution for that market, for that problem statement. But as we move more and more to a data world where we are seeing the operators transition from maybe bandwidth wholesalers or broadcast markets, moving towards data markets, moving toward to become it's becoming managed network providers, really looking at satellites as a network asset in their ecosystem. I think the software defined provides the kind of flexibility that a more traditional system doesn't. And so it really is about what the problem you're trying to solve. What is the right technology solution? And we think the future, being data, being networks, the software defined is really a necessary element to that and a key enabler.
And maybe drill a little bit more down on that one. So, we've heard you describe, well, we've heard kind of generally before described the 702X satellites as being the layer 2 network switch in the sky. So that's very interesting. Try me to help us to understand that. So what does it mean for customers, and maybe give a real case example of how you kind of see that working out in real life.
Yeah. So when we think about how FSS, fixed satellite service systems, or maybe a traditional kind of forward and return links to users, where a user terminal will send data back to an operator's gateway, and then at the gateway, the data is routed back out through the satellite out to another user location. Very, very traditional architecture for how data services are done today in from space. When I've used the term a layer 2 network switch in the sky, if you think about a terrestrial network where you can have an any-to-any connection, like a mesh network, what the software-defined capabilities of the 702X provide is that same kind of any point-to-any-point connectivity. So the concept of a gateway or a user terminal is really blurred. And so what does that mean to the user? So what that means to a user is they can set up some very unique network configurations. Again, it's all about the network. So if a business wants to have a virtual private network connection between two office towers, a remote station or a home base, they can set up a direct point-to-point link, through the switch without going back through an operator's data center. Similarly, if you have for example, an emergent need for disaster relief, setting up a local VSAT network, a local communications hub, where you need to backhaul, 4G, 3G, 4G cell services. You can do that very quickly by simply putting, essentially making that network connection from space, putting quickly lighting up a beam in the right geographic region, connecting it back to where you need that access point, and the network's established. So it provides the same kind of flexibility that one would really have in any kind of terrestrial network.
Interesting, yeah. So maybe as well, another point, what we know historically, this industry has also been a lot about flight heritage and reliability as kind of the key important parameters for many satellite customers, or customers considering procuring satellites. So curious about, are these new 702X satellites more like a clean sheet design, or is it more of an iteration of previous platforms or satellites?
Mm-hmm. Well, so when we conceive the 702X, and it still has the 702 moniker, which is a platform, high reliability platform that we've had now for well over a decade. So Boeing has been building satellites for many decades and have a very, very clear understanding of, and a lot of intellectual property and how to make them reliable, long lasting, to meet the customer's needs. So we didn't want to throw the baby out with the bathwater. So taking that heritage of reliability, mission assurance, and evolving it to support the needs of current and future markets, and then taking the payload and radically changing the design. So kind of look at it as an evolution of a platform that has high reliability and availability, and revolutionizing how we treat payloads. So payloads I think are still, built very much like they've been for many, many decades. And we knew going into a fully software-defined, fully networked world, we needed something that was fundamentally different, a fundamentally different set of technologies, manufacturing techniques, and that is the X part of the 702X, where we're taking. And so we've taken an evolution of a high reliability platform that our customers depend upon, and now marrying it with a advanced phased array based software-defined payload.
Good. So maybe kind of moving as well into more of a commercial discussion. So you obviously got some of the commercial operators lined up. We're well aware of the SCA with the OVB Empire constellation on the construction right now. So if you look at kind of from the commercial interest, commercial tractions, where do you see the kind of the biggest commercial tractions today in commercial side?
Well, I think over the past, let's say over the past 12 months, it's been pretty exciting. There's been a reemergence of communication with operators. I think as we've seen certainly at Euroconsult over the past few years, a lot of discussion about the slowdown of the GEO marketplace, where we would have traditionally, say 20 satellites a year, and a very kind of standard procurement process for a very long time. And certainly as noted at Euroconsult, that had slowed down over the past few years, and it was I think a point of concern. And certainly the pandemic has not helped that. Other market disruptors, a lot of market forces playing into that contributed to that maybe sort of quiet period. It's quite exciting. In the past 12 months, we've seen operators, kind of starting to reemerge, rethinking about their business plans. I think getting better clarity on where they see their markets going. And so there's been quite a bit of interest now in having discussions to see how the 702X really fits into these kind of emerging market plans that the operators have. So a lot of discussions going on. It's quite an exciting time.
That's great. And some of those discussions are now also turning into RFPs, or you see still a little bit more early stage of those discussions, or you see some kind of follow through kind of into real RFP processes, I would say.
Yeah, so all of the above. And I think, as we see a lot of the traditional operators or regional operators looking at how their markets are changing, having some really interesting conversations about, it's a new market. We've got some very new technologies, and, sitting down at the table and understanding how those technologies can not only support where they see their markets going and their business going, but how might that also influence growth and additional sort of accretive aspects of their where their current market plans are.
Okay. And on the government side, is there some, where do you see some uses there? Obviously, we've seen a different kind of levels, increased investment and interest from different governments around the world. Do you also see that at some of your, the commercial satellite solutions you provide, is that there's some increased heightened interest from governments?
So historically, here at Boeing, we've had a very, I'd say, close relationship between our commercial and our government satellite businesses. So there's been a lot of platform technologies really go back and forth and are shared across those business spaces. And so, right now we're also in manufacture for the wideband global SATCOM F-11 satellite, which is a high power militarized variant of the 702X. So it's leveraging the same software-defined technologies at Mil-Ka and X-band for the US government. And here again, we really see as the entire kind of SATCOM industry, whether it's for commercial operators, whether it's for government operators, moving more and more towards a networked world, the 702X technologies are really applicable across all. And so we really see that as a strong part of our future. And in addition to what we have in manufacture today, there are other sort of prototypes and developmental activities underway to kind of further expand these technologies.
Yeah, that's interesting. And maybe also talk a little bit more about one of the things about 702X is about that it could be fielded for various orbits, like LEO, MEO, and GEO. So maybe try to help me to understand how that's possible. You give this flexibility. Typically, we see, different platforms for different kind of orbit solutions being available. So maybe give us a better understanding on that flexibility.
Absolutely. When we set out to architect this fundamentally new technology, we did it with the forethought that the future will be multi-orbit. there are applications, especially in a networked world, where MEO is a wonderful sweet spot. There are applications, of course, where LEO is very exciting, and where GEO is still very relevant, and still is some prime beachfront property. So we did that with malice aforethought to make the design very scalable, to scale up to the kind of power that one needs for the GEO orbit, as well as scaling down from a size, weight, and power to fit on smaller platforms. And as you know, about 2 years ago, Boeing acquired Millennium Space Systems, which is they do LEO small sat systems, and have been for quite some time. We have many designs that we've done now, taking the 702X technology and applying it to a small sat platform with Millennium. So it scales in size up to GEO, down to LEO, as well as I noted before with the wideband global satcom example. It also scales in frequency. So we have a variety of different frequency options, all within that same fundamental architecture.
Good. And maybe talk a little bit as well about some of the, we talked a lot about 702X, but there's also maybe some other commercial satellites and service portfolio. You already referred to Millennium as well, and maybe some of the other strategic investments and partnerships you've made recently. So maybe give us an update on some of the latest activities.
Yeah, happy to. So as I noted, the 702X or the 702 platform, is still a high reliability, kind of our flagship platform we're using not only for the C-band satellites. We have a very high powered version we're working with our customer Viasat on, with a north of 25 kilowatt platform, which I think is also a very exciting system that's going to be deployed here very soon. So there are, as you noted, you asked the question earlier, is it an all or nothing solution with software defined? Absolutely not, right? It's we have a core platform. What are the right sort of payload technologies to fit on those platforms? I think certainly our investment with Millennium has been huge for us. They bring not only a very strong culture of rapid prototyping and the infrastructure to support that, but bringing that now under the umbrella of Boeing, it enables us to provide them, manufacturing scale that maybe a small company wouldn't necessarily have. And one thing that Boeing is outstanding at is manufacturing. We make a lot of things, so being able to bring in additive manufacturing is certainly a key investment we've made throughout the Boeing company, as well as other kind of advanced manufacturing processes, being able to bring those not only to our legacy businesses, but also help to bring that scale and maturity into the Millennium business as well, along with being able to blend a lot of the mission assurance and reliability, expertise and intellectual property we have here into marrying that in with a rapid prototyping small sat house. I think also gives us a lot of advantages where now we've got a more complete multi-orbit platform to host whatever kinds of payloads, whether it's communications or otherwise.
Yeah, so maybe picking up on two things you mentioned, rapid prototyping. So maybe speed to market, obviously a key criteria, and affordability. Obviously, I think you already made great strides into it, but there's always how can you improve it, right? Obviously, so maybe first, looking back, what were kind of the major kind of changes that you applied to be able to reduce the time to market and reduce the cost, basically. That's the first question. And then maybe looking forward, or if you have some areas where you think Boeing, but maybe as an industry we really can improve to kind of bring back down costs even more.
Well, maybe I'll start with the second piece of that. As an industry, I think something that's been a very exciting trend in the industry as access to space has become much easier with a lot of launch companies coming into the foray. And then I forget the count we had at the recent satellite show, but I think it was a 3-digit number of launch companies out there. So access to space, I think, has fueled a significant growth in the component market. So we have had a lot of sort of traditional suppliers of platform components, and that has really expanded substantially. And so I think that's very exciting. So I think access to new technologies that a lot of these startup companies are bringing to bear, to bring into the marketplace, I think that itself will help to support affordability, support time to market, and something that I think as an industry we can all take advantage of. With regards to what we've been doing kind of specifically within Boeing, as I noted, a lot of manufacturing expertise, certainly from our aircraft lines, but throughout the Boeing company that we are able to take advantage of in our space business as well. Noted additive manufacturing as an example, but also as we set out to design the 702X, we really started incorporating a new suite of technologies and developed a lot of new manufacturing processes to drive a very high level of automation. And that automation not only improves affordability, but also supports predictability and reduced manufacturing time, short time to market. And so that overall value proposition then can be carried forward into our customer base.
Okay. So is there like, what is kind of traditionally, I mean, historically, I think it was like 2-3 years, maybe for 2 years, maybe to manufacture a satellite. Where do you think we will get to? What kind of timelines you think will be achievable? As we move more into automation, more into standardization, any indication that you think you're currently planning to achieve, or maybe you think you can achieve in the coming years?
Certainly. So one of the biggest challenges with the kind of time from an order to delivery is in the supply base. Right. So a lot of the components being very long lead, high reliability components, often taking themselves 2 years to produce. And so back to the earlier point about a broader supply base coming, that has emerged. I think that is going to be a key enabler to reducing overall time to market. And then it ties into, inventory management strategies and such, so that from the time you get that order, you have a fairly kind of a highly predictable inventory system to be able to get through manufacturing. But another key element of that is, and I think this is where the software-defined aspect of the design really comes into play, is that these solutions, while these solutions can be essentially programmed to be bespoke, but are fundamentally the same hardware. And sometimes we think about them like a white-tail aircraft. So you hear the Boeing company, a lot of airplanes. The airplanes come off the line and they're kind of the same airplane. And then the customer gets it. What color do you want? What interior choices do you want? When we have a more traditionally designed satellite, you've got to decide where a beam is going to go. You've got thousands of cables and waveguide and components you need to specify, build, integrate, test. With the 702X, we have a platform that is largely identical from application to application. And so from the time to order to manufacture, it allows us to have a more predictable supply chain strategy, and then can be programmed to support a customer's application. Then if you kind of extend that a little bit further, now you've got an asset on orbit, a network operator customer has on orbit. They decide they want to move something that is designed or that's currently operating, let's say over Europe, Africa, and they want to move it over to cover the Americas. With a traditionally designed satellite, that is not really a possible thing to do, certainly not efficiently. But with the software-defined satellite, you can move it all the way, move it to the other side of the planet, reprogram it, and provide an entirely different coverage region. And so that software flexibility not only supports, I think, unique business models and kind of opens the aperture on how they can be used, but also working backwards, if it's the same satellite, the same components, same parts, same manufacturing, that allows us to drive cycle times down substantially.
And speaking just about the supply chain, obviously we've heard quite a bit about, COVID-19 kind of impacting bit some of the supply chain and having some issues, at least in some of the launchers and manufacturers have reported on. How has that been at Boeing, and are we kind of past that a little bit, or you're still facing some of the supply chain challenges?
So we're certainly not past it, but thankfully things seem to be much more predictable, much more stable now. I'd say a year ago was a lot more challenging, but throughout the pandemic and continuing today, we work very closely with our suppliers. Thankfully, we have very good relationships with our suppliers. So when issues happen, when there's say a mandated shutdown from a government, or there's a sanitation issue that needs to be addressed, and a production slowdown happens, working very closely with our suppliers to manage our way through that. Thankfully, that has not substantially impacted our ability to continue executing. Here at Boeing, we are an essential industry. within the United States. And so our production never shut down. We had, our factory was continuing to operate throughout the pandemic, continuing today. And so it really is something that we've had to manage. And I say, thankfully, we've had some really good relationships with our suppliers to be able to work through the speed bumps over the past 18 months.
That's good to hear. Let me see if there's some questions from the audience, and please feel free to submit those. We have a few minutes left. So maybe one question as well is on the current status of Boeing's V-band filing. Could you comment on that? Yeah,
absolutely. So, we are still very excited about that filing. Anytime Boeing enters into a new business venture, we do it with a lot of deliberation to make sure the business case is sound. And so we have continued to work on that, as well as maturing the underlying technologies to support the deployment of that constellation. Now, as I noted before, we really see the future as this multi-orbit future. As applications become, more broad, there are solutions that are best met at GEO, MEO, LEO, and we certainly see V-band as an exciting part of that future, and we are continuing to develop that.
Okay. All right. Yeah, our time is almost up. So maybe I just want to kind of, as well as we just only, well, first of all, we have in-person events, right? There was Satellite Show, National Space Symposium. So we're returning back to in-person events. And we obviously also looking forward to the World Satellite Business Week, only 2 months away in Paris. So maybe if for you as well, what are you looking most forward to come to Paris and be on stage with us?
Well, I'll say the Satellite Show we were at a few weeks back was, I would say, very exciting, very refreshing to meet with customers, suppliers, friends. It's a small industry, and it was great to be able to sit down and talk with folks again and understand, the things that have been changing and where business outlooks from, our competitors or our, suppliers and customers, how things are looking for them. So it was really great just to sit down and see that. And I think as well, seeing some of the emerging technologies and some new suppliers that in the exhibit hall that we really hadn't engaged with before. And so that was also very exciting. So I'm looking forward to that again in Paris. And of course, the weather in Paris in December, looking forward to that as well. So I think getting the opportunity to meet with customers again, follow up with the discussions we've had, last month at Satellite, I think is going to be very interesting.
Sounds great. Well, time is up. Thank you, Ryan, for this insightful conversation. Looking forward to see you in Paris.